So here is a photograph taken by Edgerton of Denny Shute as he strikes a drive. The shutter is left open, exposing the film to a long period of time. However, a strobe light lights up at a frequency of 100 hertz. So we can see motion because in the hundredth of a second between each flash, the golf club or the ball moves a certain distance. And so motion is evident from the fact that these are in different positions. We can see the club is speeding up here because the clubs each time are further apart than before. So here we have positive acceleration with the club speeding up, and here we show negative acceleration with the club slowing down and ultimately coming to rest. So the golf ball sits right here and is very, very bright because there's many flashes exposing it. But once the club hits it, it takes off. So the club hits the ball here, but there's no flash. The next flash is when the club is here and the ball has already moved this far. The golf ball has moved about twice as far as a golf club has after they hit. And when the golf club is here, the ball is already this far. When the golf club is here, the ball is off the screen. And again, we see that the distance between consecutive pictures of the golf club is about half as far as consecutive pictures of the golf ball. So the golf ball is going about twice as fast as the golf club. Now, exactly how fast we'd like to know. We know that the time between these pictures is 100th of a second. But what is the distance? Well, we have a reasonable idea. This guy was pretty tall. This is maybe 6'2". This is his head. His elbow is up here. I'd say this is about 2 meters. We cut that in half. We have 1 meter. And then I can cut it into fifths, and I have 20 centimeters per section. And we can measure and see that the golf ball has gone 20, 40, 60, 80, about 85 centimeters in 100th of a second. And so please do the math and see that the speed of the golf ball is about 85 meters per second. Is that fast? Yeah, I think it's really fast. It's 85 meters is about a football field. So in about 1 second, it would go about a football field length. Where the golf club is only moving at about 45 meters per second because it has moved 20, 40, about 45 centimeters, which is a little faster than it was moving before it hit the ball, about 60 meters per second, because it's moved 60 centimeters in 100th of a second. The impact happens over a very short period of time. As you can see, maybe when the golf club face was here is when they first made contact. Here is where the golf ball is compressed completely, and likely by the time the golf club has moved to this position, the ball will no longer be in contact with it. The golf club slows down and the ball speeds up because of a normal force between the two, a force pushing the golf ball, accelerating it off the tee, and a force that slows the golf club down. This is a single normal force. It's a repulsion between the two, so the forces on these bodies are equal and opposite. Or you could say the change in momentum of the golf ball is equal and opposite to the change in momentum of the club. And change in momentum is mass times change in velocity. Because the golf ball has a tiny mass compared to the club, in order for them to have equal and opposite impulses, changes in momentum, the golf ball gets a huge change in velocity compared to the change in velocity of the golf club. So to be more exact, what is the change in speed of the golf club? Well, we see that the golf club's accelerating when it hits a ball because here the distance is about 46 centimeters, and here it's about 58 centimeters, and here it's only 45 centimeters. So we can't really measure this to get the speed at this point because when the club hits the ball here, it slows down. So if we look at these two, we see that this corresponds to 46 meters per second, 58 meters per second, and so in 100th of a second, its speed has changed by about 12 meters per second, corresponding to a rather outrageous acceleration of 1,200 meters per second squared. So this guy is pushing the club pretty hard as he swings through this. And so I'm going to estimate that if we took the distance right when the club was here, it would correspond to 65 meters per second. So the club's velocity when it hits the ball is about 65 meters per second. I'd say plus or minus 3. And after it hits the ball, it's about 45 meters per second. So it loses about 20 meters per second when it hits the ball. So if we look here, the impulses on the ball and the club are equal and opposite. So the change in momentum of the ball must be equal and opposite to the change in momentum of the club. Now the change in velocity of the club is about 20 meters per second. The change in velocity of the ball, it picks up about 85 meters per second. So you can see that the club then must be more massive than the ball by a little more than a factor of 4. Please check some sources and see if we're close. Thanks. Bye.